Hi, today we're going to look again at simultaneous equations involving quadratics, but this time it's next level because it's going to get a little bit tasty in this lesson. So here goes. Solve the following simultaneous equations. If you're feeling confident, then give this a go. There is an approach that you can use, but otherwise, watch on. Okay, first of all, I'm going to remind you about these curves. In fact, this top one is a rearranged form of y equals mx plus c. It's not in the form y equals mx plus c, but it will still be a straight line. This second equation you might recognize is not a quadratic, it's like a parabola. Okay, so although the title says quadratics, it's okay. It's still got an x squared and it's in this case a y squared in it. But in fact, the equation of this gives a circle. It's got a radius of 5. This is in the form x squared plus y squared equals r squared. That's not actually essential to the problem, but it's quite nice to see, I think, because again we see that there are two intersections and we even see what they are, but we want to be able to find these algebraically. Now this time we can't have y equals and set them equal to one another because I've got a square. I could try and square root it, I guess, but that's going to lead to bad times. What we have to do instead is remember that the y values are the same at the particular point. So here, the y values of the straight line and the circle are the same. So actually this is the same as this. And what we could do, therefore, is make y the subject of this one and substitute it in. So what you would do is you would do 2y equals 10 minus x, and then y equals 10 minus x over 2. And then replace this y here by that. However, again, that will lead to not quite so much bad times, but there's a fraction going on here. So it's just overcomplicating things. There is a better way, and it's something we've not done before, but there's nothing special about replacing y by y. In fact, we know that at these points, the x values are also the same. So what we're going to do is we're going to rewrite this as x equals 10 minus 2y, and that is going to be what we substitute in. No fractions, it's going to be easier. So we can write down 10 minus 2y squared plus y squared equals 25. This is called substitution. I'm actually solving simultaneous equations using substitution. And actually, last lesson was substitution as well. But if you have y equals and y equals, it's a simpler substitution than what we're doing here. Now we've got to solve this. We've got to solve it for y. We've got double brackets here. Don't forget, this is actually 10 minus 2y times 10 minus 2y plus y squared equals 25. That's what that little squared there means. And then I need to multiply this out. So I'm going to get 100. I'm going to get minus 20y, another minus 20y. So I'm going to bring that all together, minus 40y. And then minus 2y times minus 2y. It's quite easy to make a mistake here. It's actually plus 4y squared. Let's just take a moment to remind ourselves about that, because what I'm doing is I'm multiplying the numbers together, minus 2 times minus 2, which gives me 4, and then I'm multiplying the y's together. Absolutely fine to do that. And then I still need to add a y squared and set it equal to 25. Okay, we're getting there. Now I combine like terms, so I've got 5y squared minus 40y plus 100, but in the same go, I'm going to actually minus 25 from both sides. So it's going to become plus 75 equals 0. Why have I done that? Because I'm always trying to get my quadratic equal to 0. Then I can solve it. This doesn't look very nice, but actually a little tip, when you've got a quadratic with a number in front of the y squared, we'll look at one a bit more complicated than this in a minute, but look for a common factor. And actually 5 goes into all of these. So suddenly that makes life easier. I can divide through by 5, and this is what I get. And we are back to where we were last lesson, factorizing a quadratic. So the new steps, if we're just going to summarize so far, is the fact that I'm solving for x, that's a new step. The fact that I need to then make x the subject, and then I'm actually replacing an x squared by x. I'm not just setting things equal, so I had to do this. I had to expand double brackets. And then just a reminder that I can go from here to here as well. We're not finished, remember. We've still got to solve this in terms of y, but we're nearly there. So two numbers that multiply together to give 15 and add to give -8, they've got to both be negative. Turns out that it's y minus 5, y minus 3 equals 0. So close now. Y equals 5 or 3. And then finally, we just need to sub back in. When y equals 3, let's take the smaller one to start with, x equals, and all I do is I substitute my y back into here, the simplest one, rather than the squared one. So it's going to be 10 minus 6, it's going to be 4. And when y, that was meant to be when y equals 5, actually x is equal to 10 minus 10, it's going to be 0. And we see that we get these points. We've got 3, we've got 4, 3. If you have to read the coordinate the other way around, 4, 3 is this one, and 0, 5 is this one. So well done on solving this quadratic equation, this simultaneous equation involving a quadratic, I should say. Okay, in this case, it's a circle, a bit different from a parabola, but it's the same process except for this extra little step. We're nearing the end of our study of simultaneous equations involving quadratics at GCSE level. We've looked at equations where it's y equals something, and one's a quadratic and one's linear. We've then looked at how you might solve it by factorizing or using the quadratic formula. Today we've studied equations where we don't have y equals and y equals, so we might have a function, an equation involving y, such as a circle and then a straight line. And just to finish, we're going to look back at y equals and y equals 1s, but we're just going to see a slightly different take on it. So let's do this. To deal with this question, again, we're going to set the y values equal. So it's going to be 2x squared equals x plus 6. And I can rearrange this to give me 2x squared minus x minus 6 equals 0. And this is where it becomes a little bit different, because previously we had a factor of 5 that went into all the equations, but there is no common factor here. So I'm having to factorize a quadratic with a number in front of the x squared that doesn't cancel down. So I just wanted to revise how to do that. Okay, we're going to do it by factorizing. Now, can I just say, so if this question came up in a calculator paper, you could, of course, use the quadratic formula. You could set a equal to 2, b equal to -1, c equal to -6, and it would all be fine. But you might be expected to solve this kind of a question by factorizing. It could come up in a non-calculator paper, or you could be asked to, I don't know, you could be asked to use an algebraic approach somehow. In any case, I'm just trying to remind you how to factorize this kind of thing. So if this is going to factorize, the only things I can put in the brackets would be 2x and x to get my 2x squared. Of course, it could be the other way around, but let's do it like that. And now I need two numbers that multiply to give -6, but they don't add to give -1. It's an interesting take now, because it's going to be 2x times a number and x times a number that are going to give me the -x. So how do we deal with this? Well, let's just try some numbers, really. Okay, we might start, and I'm going to write it below because we're just going to try this out. Maybe we start with 2 and 3. One of them's going to have to be negative eventually, but let's not worry about it at the moment. If we do the 2x multiplication, we're going to get 6x. And if we do the 2 times x, we're going to get 2x. And we see that this isn't going to work. There's no way I can combine that to give -1x. So I'll just put a little cross by it. The natural thing to do is just try them the opposite way around, 3 and 2. Because then I'm going to do 2x times 2, 4x, and 3 times x, which is 3x. And this will work. If I can make it -4x, then I'm sorted. I just need to put a -2 there. And we can fill it in now. It's going to be 2x plus 3 and x minus 2. equal to 0. So we've actually factorized this. Let's just finish it off then. It must be that 2x plus 3 equals 0 or x minus 2 equals 0. And here we can jump straight to the solution, x equals 2. We've got a little bit more to do here. You're going to need to minus 3 and then divide by 2. So you actually get a fractional answer. But there we go. Those are our solutions to this quadratic equation. We've nearly finished it. We've just got to solve the simultaneous quadratic. So substitute back in. When x equals 2, I'll deal with that one first. Y is going to equal 8. I've just put it back in to here. 2 plus 6. And then lastly, when x equals minus 3 over 2, y is going to equal, okay, so this is actually minus 1.5, so minus 1.5 plus 6 is 4.5, or 4.5. I can write it as 4.5. I could write it as 9 over 2 if I want to write it as a top-heavy fraction. So this was just one final example on simultaneous equations involving quadratics, just to remind you, sometimes we need to factorize quadratics as well.